So make sure that you have your digital interactive notebook updated. And let's look at the assignment for today. Number 2 will be bonus. Number 1, this is all together. So you would look at the sequences, the graph, and then this is our recursive formulas. So we'll look at the first one. Whenever you look at your sequence, you have to decide whether it's exponential or linear. So this first one, it only gives you parts of the sequence. So from 2 to 4, we're finding the pattern, and then from 16 to 32. From 2 to 4, it looks like it could be plus 2 or times 2. And 16 to 32, it could be times 2 or plus 16. So you want the same pattern. So the only one that they have the same is times 2. So 2 times 2 is 4. 16 times 2 is 32. So then we need to find the other numbers in the sequence. So 4 times 2 is 8. 8 times 2 is 16. 32 times 2 is 64. What kind of function is this? We've talked about linear and exponential. It has a constant rate, but is it linear or is it exponential? Okay, why is it exponential? Yep, because of the multiply, it's an exponential function. So we need to find out where A is going to go, one of these 4. So this first one is linear. I'm going to put an L there. So that can't be it. This one, that's exponential. I'm going to put an E here. Does this match this one? Looks like it's at like 0 and then less than 20. No, because that goes up too fast. See how it increases really fast? So it can't be that one. What about this one? Is this linear or exponential? Exponential. It has that curve to it. So let's see. Could this be it? 2 is close to 10. 3 is close to 15. 4 is close to like 32. And then 5, 64. That looks like it. So I'm going to put an A here. And this last one is linear. Then you decide out of these, which one's the recursive rule. So what was the pattern? It was times 2. So out of these, which one has the times 2 pattern? Yeah, it's right next to it, actually. It's the third one. So does it start at 2? Yes. And is it now times 2? Yes. So we'll put I. So you'll complete the rest of that table. Okay, I want you to go to the back now. So turn it over. Everybody turn it over. Everybody turn it over. Let's look on the back. And this is over what we did yesterday. If you are multiplying terms and you have like bases, what do you do with those exponents? Yep, you add them. So remember these notes from yesterday? Multiplying like bases. So down here, when we multiplied like bases and we had these bigger terms, we would put our numbers out front and then group our variables right next to each other that have like bases. So that's what you'll do on these problems. So let's look at number 2. So you put the numbers out front. I don't really like this, but I don't know. 6 multiple times, I just don't like it. 6 times itself 3 times goes out front. Because we have a 6 here 3 times. And then we look for other like terms. Looks like we have 2 x's. We have an x to the 3rd power times an x to the 3rd power. So those are these guys right here. And then we have y to the 6th power and y to the 3rd power. So we are rewriting it and changing the order so we can see what are our like terms. So with these numbers out front, we multiply. We do 6 times 6 times 6 because it is multiplication. So go ahead and find what that is. We can use our calculator on that. What is 6 times itself 3 times? Oh my gosh, that was loud. What is it? Yeah, 216. And then what do we do with variables? What is our rule? Yep, add them. Same basis, add the exponents. So if you need to write that at the top, multiplying, I want everybody to write this on top. Multiplying like basis, add exponents. All right, so then what will we have for x's then? What do we do with these 3's? Add the exponents, right? So that's to the 6th power. And then what about the y? Add these to the 9th power. Okay. All right, so you have some time in class to finish this front and back, and it'll be due tomorrow.